mentioned the Antiope occultation. Of course, those of you who are at the 2011 meeting, actually participated in that event, and then we talked about it at last year's meeting. I showed these same slides, so I'll go through these slides a little bit quickly, but enough so that the people at the meeting here who weren't at last year's meeting know about this event. So it's one of the most successful efforts that IOTA has ever done, and let's see now, how can we squint this so we get a better view? Oh, okay. So, yeah, if you could compress the view in the vertical direction a little bit so we get the horizontal. It's cut off a little bit on the left side.
By closing that window, but I think it's cutting.
Right. I don't know if there's a way. Well, that's good enough, I think. So anyway, this was this occultation of LQ Aquarium. Oh, I should also mention in Paul Mary's talk, he talked about his hip number star of his fourth magnitude. That star that he observed with the Padua occultation was Eta Scuti. So these bright stars have other names, and we ought to. The Hipparchus catalog was only generated back in 1997 or so, and so if you want to look at any literature before that, you're not going to find any hip numbers. It's a 6.7 magnitude red giant star by the double asteroid Antiope. So we talked about some already. Okay, next slide, please. Now this just shows the path over northern California and Nevada. It just shows for 120 kilometer sort of combined diameter of the two objects, but because the two objects were two 90-kilometer objects that were separated by about 150 kilometers, and they were oriented sort of at a 45-degree angle to each other, we really wanted to cover everything between the two black lines here to be sure to cover both events, including the uncertainty in the path prediction. And it turned out the actual path was quite close to the predicted path. Next slide. Now this just shows that 5.5 revolutions, I think these have about a 5-hour period of rotation around each other. Do you remember what that was? I don't remember exactly, but 5.5 revolutions before the event, it's almost 12 hours, I guess. It's a period of revolution around each other, their common center of mass. On July 15th, Bill Merlin made observations with the Keck telescope with adaptive optics to resolve the objects and get an update of their location. That was great. It showed that there was just a small correction to the nominal prediction we were already planning. And Bill Merlin managed to make it to the IOTA meeting in Rockland, California from Hawaii in time to participate in the occultation observations as well. So, next slide. And it just shows the picture we took at the IOTA meeting showing Scotty, who got the Homer the Bull Award that year. And we've been talking about Walt Robinson and the IOTA VTI and the red shirt on the third from the left on the bottom. I'm in the middle. And Eberhard Bredner is next to me, just below the J in July. He came the farthest, coming from Germany, but we had a couple of people from France who were there as well. Next slide. And this just shows one of the pre-point charts that we had for the event. I talked about those yesterday, so and of course it doesn't show up too well on the web here, but we had a bunch of these prepared for our mighty minis that we used mostly to record this event, but there were some, of course, other telescopes used too, but for the pre-pointing, mostly these a few MIDI systems. Next slide. And this just shows a problem we had with that event. There was a full moon that was only 10 or 11 degrees away from the target star. So we had to be very careful in shielding our telescope to avoid that moonlight. We have a somewhat similar situation, but not quite as severe, with the event coming up on October 21st, the Patroclus occultation, Patroclus, however you pronounce it. But it's a slightly dimmer moon in 86, and I forget what it is, but it's we have using just the dew shields of the MIDI telescopes show that they will be enough to cut down the moonlight. And according to Scotty's observations of the event, of his test that he did for that event. But anyway, this event, we actually had a few people who lost data because of the bright moonlight and not proper shielding. But with the mighty minis, we had to tape black cardboard paper in the direction of the moon, in the upper left side of the chart, of the telescope, and that provided, gave us the shading to actually image the star well. With the pre-pointing, during the pre-pointing time, of course, the moon was not an issue because it was farther away. Next slide. This just shows setting up one of my mighty mini systems. I ran 10 stations for the event, and 4 of them were in the path, the 4 northernmost ones, and all successfully recorded the occultation. And then I had 6 other stations, 3 of which failed for various reasons. But we got 4 other events, recordings that showed that there was a miss in the more southern area. Next slide. And this shows the light curve of the occultation that I got at my station, the northernmost station number 1, showing a very clear. This is the MIDI system with a 80 millimeter rather than the MIDI, and we can see that there was a clear gradual disappearance and a gradual reappearance, which had different slopes because of the different angle on the asteroid that the occultation occurred at. So that the angular diameter of the red giant star caused these gradual disappearances and reappearances, and we were able to Dave Harold did a good analysis of all of the observations that determined the angular diameter, showed that it was in good agreement with the astrophysically theoretical diameter for this star. Next slide, please. And this is the famous chart showing the two events that we resolved in quite a bit of detail. There was, Scotty Dagenhart was planning to cover the northernmost regions of the event, but he telephoned me in the afternoon, as he got up into that area, saying there was a big mass of clouds and he wasn't going to be able to cover that. And so I made a phone call to Steve Preston, and he and Tony George and a couple of other observers were going to observe from central Oregon to observe this, and they had plans farther south. So I told them to redeploy to cover what Scotty wasn't going to be able to get, and you can see they were quite successful in doing that. They set up a few remote stations as well as attended ones, so they only had, I think, 3 people running about 6 stations, something like that. And the northernmost one had a miss, I think, and so it just sort of perfectly got. But there was a little bit of gap in what Scotty couldn't do here. But overall we got a pretty good shape here, and we got a good shape of the southern one too. This particular chord I thought had a little dip right, here. There's a kind of a flat area just in the curve of the asteroid that missed, the narrow gap between those 2 stations. But it's pretty shape is pretty well constrained, sort of a Pac-Man type shape. Because of this large crater, we talked about that a little bit yesterday, that there's this large crater on the left side of the southern component. And there's a gap here. We did have coverage planned in that area that we should have paid attention to the coverage, because the stations that were in that area were all in the San Francisco region, and in the Pleasanton area, the Livermore area, the area just beyond the Bay Area. They weren't in the Central Valley where the rest of us were, where we had good clear skies. And I lived for 4 years in Sacramento when I was in high school. And my father worked for the state of California, and I should have known that the Central Valley always has clear sky, but the coastal regions don't. They often have marine clouds coming in, and the marine clouds were unusually strong. In fact, we actually had marine clouds in the Central Valley in the mornings before the event, but not the morning of the event, fortunately, but there were these other clouds coming from the northwest that did cause Scotty problems. But there were also clouds over San Francisco and the Bay Area, and they got into the Pleasanton area, and I could see from Tracy, from our site there, I could see the clouds just lapping right at the edge of the coastal mountains that were, right at the edge of the Central Valley. So we should have had some stations in the Central Valley, just 1 or 2, to cover them just in case that happened. We would, but that's how that gap formed. These show the stations that these 3 were ones I don't know. Okay, anyway, show the next slide, please. I think we're all impressed with this good result, and all these stations in between. Anyway, and we want to write up that event as we talked about yesterday in the publications. Only 3. It was 11 days later. There was another occultation, a good one, of the 4th magnitude star 4 Tauri by the small asteroid Hertzsprung. And the statistics were quite poor for this event. The blue lines show the predicted northern and southern limits, but the red lines are the 1 sigma lines. And we wanted to cover a little bit more than that. But I decided to, since it was such a bright star, I could use mighty minis, and it was early in the morning, so there was lots of dark time to deploy for this event. So I decided to try to set up 10 stations to observe it, and managed to successfully get 9 stations running, and 2 of them failed. Unfortunately, 1 was in the path. But we had also some local observers who just observed from home, my southernmost station was not too far from here. It was just west of West Palm Beach. And the mosquitoes were horrendous there. I got 100 mosquito bites. But the path was the actual path was in the north, and I got 2 hits. And my main interest in doing that, because this is such a bright star and you get such high resolution from these events, much more than you can do from any direct observations from the Earth's surface. So you can so you can resolve, and this is a Stucco type A star, which might be a double star, and Stucco class A stars tend to be double more than the later class stars. So I wanted to see if I could resolve this star as a double. But I got 2 good video recordings of it, which showed that the events were quite sharp, and showing that at least to my equipment down to delta magnitude of 4 or something, at least that the star is not double. And I got observations on both sides of the asteroid, so at very different position angles, which would rule out whatever geometry the secondary might have been if there was one. But anyway, if you could show the next slide. This just shows the sky plane plot then of the observations showing.
I'll bring the chat back up just in case somebody poses a question.
Oh yeah, right.
Okay.
Okay. So, okay. Right. Okay, yeah, they're asking about the, yeah, they just have some questions about the door prizes. Yeah, you have to, the website you have there for is www.rasc.ca, but you have to add /IOTA 2013 to that. I don't know, is it 2013.html or just 2013? I think it's IOTA 2013. Yeah, okay, Brad got it. Okay, Brad, just go on to the next slide, please. Okay, this just shows another event late in 2011 that occurred, showing, okay. It was an 8th magnitude star called by the asteroid Arachne. Let's see, he's going too quickly here. Right. I should be able to finish this up in 15 minutes, I think. Anyway, this just shows the predicted path, and Texas was the best area to observe it. This was in end of December 28th, so the northern areas were harder to get to, and of course snowier and colder. So, but it turned out Texas had quite a bit of cloud problems that night. So we didn't really get the coverage we wanted for the event, but I did get one very interesting observation. Next slide. This just shows my plan of stations across the northern limits and the area north of there in case the path shifted north-east. But the actual path shifted southwest a little bit. This shows stations 3 to 9. I had stations 1 and 2 also here. And I did get all of those set up and running, but there were cloud problems, unfortunately, right in the southwest where the event where the event actually occurred, and most of my stations were high and dry, getting no occultation. But they were in clear sky. So next slide. Now this just shows stations 1, 2, and 1 I didn't use. I was going to have 10, but station number 3 was the interesting one. But these two were clouded out. Next slide. And this station number 3 was at a rural cemetery. There were no houses or anything around it, and so it was a great site. We set it up at the entrance to the cemetery, not actually in the cemetery, but there was a big parking area, between the road and the cemetery, and I set up the telescope right near the fence and that, and so no one even drove by or anything while I was doing that. The next slide. This just shows the observations we got. Paul Maley also made a deployment of stations across from the center line to the southern limit of the occultation, and he just had, I think his particular attended site was the only one that succeeded. All the remote ones were clouded out or other problems. But this shows my station 3, and all these other stations had a miss, but station 3 had a true grazing occultation of the star by the asteroid. So the next slide shows the light curve of these occultations. There are actually 3 occultations of the star together. There was the complete occultation that lasted about 2 seconds, and then for about a second the star reappeared, but then it disappeared again. And then it started, for a fraction of a second, then it started to reappear again, but only partially reappear. It didn't reappear to full brilliance. And then it disappeared for another half a second or so before it completely reappeared. So this is the most complex asteroidal occultation light curve that I've had. I'm very pleased to to get this. I think there's only one other in the database where there's been three. We have quite a few where there are two occultations. There's an asteroid that's sort of peanut shaped and you clip the ends of it. This is one of them. There's another one that was done in California a few years before with IOTA asteroid, which got three occultations of the in a grazing situation. So it's not a satellite of the asteroid, but a graze of the topography of the asteroid.
So you think that's a graze on the asteroid itself rather than close together and conducting or something?
Well, if you look back at the previous slide, if you can go back to the previous slide, you sort of see what's going on. So you can see these are where the events were. And of course, there could be a satellite that just happened to be in transit or something, but it's much more likely that it's just topography on the asteroid. So it has sort of a little bit of an extreme shape. These are not timing errors or anything. We had good timing on these events. Okay, switch on to the next slide, please. Okay, we've discussed this now already. So next slide, I think we're done with direction. And then we had Agamemnon. So, of course, we learned just before the meeting here, the final article, we got galley proofs of this article, essentially, and they've will be published in Planetary and Space Science in the very next issue. Which is an eighth magnitude star called by the Trojan asteroid 911 Agamemnon. We've already talked about it. Brad mentioned it before. So this is something I wrote, some text I wrote before the event, but added a few things since. Next slide. And this just shows the predicted path of the event. Path also went over part of Siberia, but it was Cephalopac K-star. And anyway, next slide. So it shows stations in the Washington, D.C. area. Brad Timerson also observed it from Newark, New York, near Rochester, and so he was, about another, view north of here. But I ran 4 stations, and there's one station that was in the middle between Dunham 3 and Dunham 1. It's Dunham 2, and that station, unfortunately, the camcorder failed before the event, so didn't get any data. But these other 3 stations all worked. And I wrote in one of my mighty minis to Lynn Talia, who observed from his home in the suburbs north of Washington in Silver Spring. Unfortunately, we couldn't get any of the other people. I tried to get people out to watch it in the Washington, D.C. area. There were 1,000 amateur astronomers in the area, but no one else other than those of us. And Steve Kennard, of course, observed it from his nice observatory with a 14-inch Cassegrain telescope. So all these others were mighty minis. And then John Brooks also observed and had no occultation out in the Shenandoah Valley. But the next slide shows Steve Kennard's light curve of the occultation. You've seen that, I think, already. We talked about that in the publications, showing how he had a strong secondary event with a single noise ratio around 9. It's a very high single noise ratio. It was about 9 seconds after the 10-second main occultation. We had a nearly central event. And of course, there were other field stars that he said none of them wavered during the time of the secondary occultation or the primary occultation. And there was twilight at this time, and the sun was 10 degrees below the horizon. But we were looking at a part of the sky that was away from the sun, so it was dark. But there was light, and with the high magnification of his telescope, you couldn't tell that. But if anything, if a bird or anything had flown through, it would have been illuminated by the twilight. You would have seen some fluttering in the video or something, and there was nothing like that. There are artificial satellites that you would see every once in a while, but you would see them trailing across, and they were all sunlit because of the geometry. So anything up that altitude would have been readily seen. So next slide. And this just shows the Kennard's observations, this and this. This was shown before, but the real shape of the asteroid, though, was determined mainly by the mighty mini observations. You needed a lot of chords to get or at least several chords to get the shape of the asteroid. And there's another story I'll maybe tell at dinner time, how I got these two chords sort of close apart. It was because the policeman stopped me at the Bay Bridge, and I'll talk about that. And I was really mad at him at the time for delaying me, but I thanked him, and nothing happened. I didn't get a ticket or anything, but because of that delay, I didn't have time to get farther north like I wanted to with that last station. And if I had, I would have gone out of the path. So it was nice to get the northern cap determined. So anyway, next slide. The next slide we'll talk about is one of the 6 magnitude star that was occulted by 28 Bellona, and I was able to convince the people I work with in Russia that this was an event worth trying if the weather was clear. And we got cooperation from the fellow who runs Skippy Sky. He made a special forecast there for us. This is in the far east region of Russia, just northeast of the northeast corner of China in the city of Khabarovsk. So Khabarovsk is a 7-hour plane flight from Moscow. It's about the same distance as from Washington, D.C. to Paris. So it's interesting. It turned out the forecast was it would be clear. So go to the next slide, please. So it just shows the previous occultation that was done 10 years before. It was quite successful. Next slide. It just shows the basic geometry. The path crossed the Pacific and actually went over southern Baja. And Rock Fleischmann tried to observe it, but had a problem with his telescope in the bright twilight. The sun was only 2 degrees below the horizon for him, when he had the problem, he lost track of the star and couldn't get back home. It was sort of too bad. But here, this is Khabarovsk, this city right here. And so we tried to deploy with one station north and the other south of the city. But the one thing to note that the sun line, the twilight line is here. We only had about an hour and a half of dark time from when it got dark enough to when we could observe. So there wasn't, and the roads aren't good enough there to travel real fast anyway. So we weren't able to deploy. I wasn't able to deploy stations myself, multiple stations. So what I did do is work with the local astronomy club there to try to get them to deploy the mighty minis. So next slide. This shows the pre-point charts that we made for the event. The event was not too far from Delta Ophiuchi, which we talked about before. That's my 6 magnitude star. Next slide. Let's see, we only had an hour and a half or so. And this just shows the bigger area around the star, and there's a nice distinctive pattern there. So next slide. The same as the previous one, but we translated much of some of the text into Russian and help with the next slide. It shows the city of Khabarovsk, the city was founded 153 years before. So about the same time the U.S. was going westward across the continent, the Russians were going eastward across Asia. Next slide. This is kind of one of the refurbished, rebuilt churches that they've built there. Next slide. And this shows one of the Siberian tigers in the local zoo. So we saw a bunch more on a China trip recently. But, next slide. And this just shows, we set up in the office of one of the fellows there. So we had mighty mini training in Khabarovsk, similar to what we tried to do with the people in Spain for the event the year before. Next slide. This just shows we were calibrating all of the cameras with the GPS time inserter, getting the pre-calibration recordings in the parking lot before we spread out through our different sites. So, next slide. So this shows how we set up 6 stations. There's one, the 4 were just Khabarovsk itself, and then 3 Star Party sites that they have. This one with Vladimirovka was, a fellow had his Dasha there, and it was a good observing site. And when I went there, where I observed and had a miss, the fellow went farther north and had a miss. But there were also observers at these other 4 places. But one problem, there were a couple of problems. The night before the event, it was cloudy, mostly cloudy. And I wanted to, during the evening before, I hoped to show these people how to actually find the star field, to have a little star party and do that. But unfortunately, but also that was on Friday. The event occurred on the day they had to work, so they didn't want to stay up late. And it did actually clear up about 11 or 12, almost midnight. But I told the people to try to use the charts and take these things home and try them out. But they needed to work the next day, so we weren't able to do that. But most amateur astronomers, even in Russia, who used to go to systems and things, they're not used to using star charts and everything. And they sort of had a complaint to me, and I had to complain to them that they didn't, weren't able to do that. But to make this work, I think it's really necessary to have a practice run before, where you can really show them the sky and the target and everything with the equipment. They were sort of expecting somewhat more advanced equipment than what I brought. You came all the way from America and you have all these little things and all that, but in order to fit on an airplane, you have to be simple. It's the whole idea of Scotty's minimalist approach. And also they complained that the star charts we had, I had too many of them. I had different scales. The problem was we had PDF charts that in the PDF versions they didn't print out very well, and so I tried to go as best I could over again. But without the practice session, then most of these observers unfortunately failed to see it. The one observer at Station 4 who did succeed and had a 5-second occultation, and the fellow here wasn't. The equipment failed. It wasn't not his ability to find it. But these 2 people who were in the path, unfortunately, because it shifted south, just couldn't get on this target in time. Next slide. This just shows we talked about the Curie occultation observed by recon. This just shows the two positive observations and then several negative, and then another positive that is it looks like a satellite. The thing was, the first time the first observations we got were Jerry Burtikers, and then I think Tom Beard, and they said something's wrong here because your times don't match. But they were using Kiwis there; they had rock solid timing. And the next slide shows the satellite and shows the two positive observations and how they were very far separated, but a very clear event. With the 11-inch telescopes, I think, that they use in the recon system, funded by NSF grant in SWIR in the Southwestern Research Institute. So we're starting to get observations from recon, and it's great to work with them. Next slide. Okay. Yeah. Now we can't show the videos together, so we can do the tour, and then if there's time, we can maybe do some videos. Okay. Right. Right. Yeah. Okay. So anyway, thanks for sticking with us, and we will resume here at 9 a.m. tomorrow morning, the new time.